Welcome to the General Chemistry 2 class. This section is on electrochemistry. This lesson is about balancing redox reaction by half reaction method. Let's begin. The previous lesson objective is to balance redox reaction using the change and oxidation number method. In this lesson, we will balance redox reaction using the half reaction method. Recall that there are two criteria that must be met: mass balance and charge balance. In mass balance, the number of atoms each type on the reactant side equals the number of atoms of each type on the product side. In charge balance, the sum of charges on the reactant side equals of the sum of charges on the product side. Although this is more considered in a balanced net ionic equation, a balanced equation must consist of coefficients that are in their smallest whole number ratio. Also, recall that there are three methods in balancing redox reaction: inspection or trial and error method, change in oxidation number method, and half reaction or ion electron method. This lesson is focused on third method. In the half reaction method or ion electron method, a redox reaction is split into oxidation and reduction half reaction. The half reaction are balanced separately and recombined in a way that the number of electrons lost equal to the number of electrons gained. Determining the oxidation, the number of elements is necessary in this method. This method is usually employed in balancing net ionic equation for redox reaction, in which spectator ions are no longer written. Steps in balancing redox reaction by half reaction method. 1. Write the unbalanced net ionic equation for the reaction. 2. Separate the equation into two half reaction. 3. For each half reaction, balance the elements by inspection if either or both or half reaction contains hydrogen and or oxygen. Do not balance them yet. 4. If applicable, balance oxygen atoms by adding water and hydrogen atoms by adding hydrogen ions. 5. Balance charges by adding electrons. Each electron has corresponding charge of -1. 6. Add the two half reaction. If necessary, multiply the half reaction by an integer so that the number of electrons lost in one half reaction equal the number of electrons gained in other half reaction. Simplify the equation either by canceling substance appearing on both sides of the equation or by reducing the coefficient to their smallest whole number ratio. 7. If the reaction is an acidic medium, proceed to the last step. If the reaction is an basic medium, add one hydroxide ion on both sides of the equation for every one hydrogen ion. Count each pair of hydrogen and hydroxide on the same side of the equation as one water molecule. Simplify the equation. 8. Check if the equation is balanced in terms of the number of atoms of each element and the charges. Example 1. Use the half reaction methods to balance the equation for the reaction of chromium 3 ion with tin 2 ion, which yields chromium 2 ion and tin 4 ion. Solution. 1. Write the unbalanced net ionic equation for the reaction. 2. Separate the equation in two half reaction. The first half reaction is the conversion of tin ion to tin ion, while the second half reaction is the conversion of chromium 3 ion to chromium 2. By looking at the oxidation number changes, the first half reaction is the oxidation half reaction or OHR, while the second half reaction is the reduction half reaction or RHR. Determining which are the OHR and RHR based on the changes in oxidation numbers is not necessary at this point. We cannot figure out which is where when the half reaction are completed. 3. For each half reaction, balance the elements by inspection. If either both of half reaction contains hydrogen and or oxygen, do not balance them yet. Look at the atom count, we can see the two half reaction are balanced. 4. If applicable, balance the oxygen atoms by adding 2 water and hydrogen atoms by adding hydrogen ions. This step is not applicable as ions do not have oxygen and hydrogen. 5. Balance charges by adding electrons. The charges in the first of half reaction can be balanced by adding electrons on the product side. The resulting half reaction involves loss of 2 electrons, implying that it is the OHR. On the other hand, the second half reaction can be balanced by adding 1 electron on the reactant side. This half reaction implies that electron is gained. Thus, it is indeed the RHR. 6. Add the half reaction if necessary. Multiply the half reaction by integers so that the number of electrons lost in one half reaction equals to the number of electrons gained in the other half reaction. Simplify the equation. For the number of electrons cancel in other overall equation, multiply the RHR by 2 by adding it to the OHR. With this, the overall reaction is given by 2 chromium 3 ion plus tin 2 ion yielding 2 chromium 2 ion plus tin 4 ion. At this point, the equation is on simplest form since the coefficient are on the simplest whole number ratio. 7. If the reaction is in acidic medium, proceed to the last step. If the reaction is in basic medium, add 1 hydroxide ion on the both of equation for every hydrogen ion. Count each pair of hydrogen and hydroxide on the same side of equation as water. Simplify equation. This step is not applicable since the ions involved do not have oxygen and hydrogen atoms. Skip to step 8. 8. Check if equation is balanced in terms of the number of atoms of each element and the charges. Each side of equation has 2 chromium and 1 tin atoms. Moreover, both sides of the equation has net charge of plus 8. Therefore, the equation is balanced. Example 2. Write the balance equation for the reaction of chromium 3 ion with permanganate ion in acidic medium. Some of the products of the reaction are dichromate and manganese 2 ions. Solution. 1. Write the unbalanced net ionic equation for the reaction. 2. Separate the equation in 2 half reaction. The first half reaction, the inconversion of chromium 3 ion to the dichromate ion is the OHR based on the change in oxidation number. On the other hand, the conversion of permanganate to manganese 2 ion is RHR. Again, looking at the oxidation states is not necessary. We can confirm which are the OHR and the RHR once the half reaction are completed. 3. For each half reaction, balance the elements by inspection. If either or both half reaction contains hydrogen and or oxygen, do not balance them yet. For the OHR, chromium can be balanced by adjusting the coefficient of chromium 3 ion to 2. No adjustment is needed in balancing manganese in the RHR. 4. If applicable, balance oxygen atoms by adding water and hydrogen atoms by adding hydrogen ions. As for the OHR, we can balance oxygen by adding 7 water molecules on the reactant side. In turn, hydrogen can be balanced by adding 14 hydrogen ions on the product side. On the other hand, oxygen in the RHR can be balanced by adding 4 water molecules on the product side and 8 hydrogen ions on the reactant side. 5. Balance charges by adding electrons. The charges on the OHR can be balanced by adding 6 electrons on the product side. The resulting half reaction is consistent with the definition of oxidation, which involve loss of electron. On the other hand, the charges on the RHR can be balanced by adding 5 electrons on the reactant side. The resulting half reaction involves gain of electron, consistent with definition of reduction. 6. Adding the two half reaction if necessary. Multiply the half reaction by integers so that the number of electrons lost in one half reaction equals to the number of electrons gained on the other half reaction. The electrons can be cancelled on the overall reaction by multiplying the entire OHR by 5 and the RHR by 6. At this point, the number of electrons lost in the OHR equals to the number of electrons gained in the RHR. Proceed to addition of this half reaction. Upon addition, simply the number of water molecules in the hydrogen ions. We can cancel the 24 water molecules on the product side by subtracting it from the 35 water molecules on the reactant side. Also, we can also cancel 48 hydrogen ions on the reactant side by subtracting it from 70 hydrogen ions on the product side. The equation then becomes 10 chromium 3 ion plus 6 permanganate ion plus 11 water yielding 5 dichromate ion plus 22 hydrogen ion plus 6 manganese 2 ion. If the hydrogen is an acidic medium, proceed to the last step. If the reaction is in basic medium, add 1 hydroxide ion is on both sides of the equation for every 1 hydrogen ion. Count each pair of hydrogen and hydroxide on the same side of the equation as 1 water. Simplify the equation. The reaction is in acidic medium. Skip to step 8. Check if the equation is balanced in terms of the number of atoms of each element on the charges. Each side of the equation has 10 chromium, 6 manganese, 5 oxygen, and 2 hydrogen. Thus, the equation is balanced in terms of the number of atoms. Meanwhile, charges are balanced since both sides of equation has net charge of plus 24. Therefore, our equation is balanced. Example 3. Chlorine gas can undergo disproportionation in basic medium, producing hypochlorite and chloride ions. Write the balance equation for the reaction. If applicable, balance the oxygen atoms by adding water and hydrogen atoms by adding hydrogen ions. As for the OHR, oxygen can be balanced by adding 2 molecules of water on the reactant side. In turn, hydrogen can balance by adding 4 hydrogen ions on the product side. Note that step 4 is not applicable to the RHR. Balance the charges by adding electrons. The charges on the OHR can be balanced by adding 2 electrons on the product side, while those on the RHR can be balanced by adding 2 electrons on the reactant side. Add the two half reaction. If necessary, multiply the half reaction by integers so the number of electrons lost in the half reaction equals to the number of electrons regained on the half reaction. The number of reaction lost as shown on the OHR and the number of electrons gained as shown on the RHR are already equal. Thus, the two of half reaction can be added right away. Note that the overall reaction can be simplified by dividing all coefficient by 2. If the reaction is an acidic medium, proceed to the last step. If the reaction is in basic medium, add 1 hydroxide ion on both sides of the equation for every 1 hydrogen ion. Count each pair of hydrogen and hydroxide on the same side of the equation as 1 water molecule. Simplify the equation. The redox reaction in step 6 has 2 hydrogen ions. Since the reaction is in basic medium, we need to add 2 hydrogen ions on the both sides of the equation. The 2 pairs of hydrogen and hydroxide ions is equivalent to 2 water molecules. Next, simplify the equation by combining water. On one side of a population, The product side was more molecules than the reactant side has, so we'll rewrite water on the product side. Thus, we have 1 chlorine plus 2 hydroxide ions producing 1 hypochlorite ion plus 1 water molecule and 1 chloride ion. Check the equation is balanced in terms of the number of atoms of each element and the charges. Each side of the equation consists of 2 chlorine, 2 oxygen, and 2 hydrogen atoms. The net charge of the reactants and product sides of the equation are both negative 2. Therefore, the equation is already balanced. To summarize in balancing redox reaction by the half reaction method, the oxidation and reduction of reaction are first balanced separately, and then combined in a way the number of electrons lost equal number of electron gained. Redox reaction in acidic media involve the presence of hydrogen ion on the reaction, while those in basic media involve hydroperoxide ion. Welcome to the General Chemistry 2 class. This question is about balancing redox reaction by half reaction method. Let's begin. Number 1. Number 2. Number 3. Number 4. Number 5. Number 6. Number 7. Number 8. Number 9. And lastly, number 10.